Hey guys, in this video, I'm going to introduce you to one of my favorite concepts in science. The reason why it's one of my favorite concepts in science is because it's probably the one area that's most applicable to something else that I really love, and that's sports. And my favorite sport is football or soccer, but I'm sure you guys all have a favorite sport too, or many of us will do, and you'll know what I'm talking about. My favorite thing to do is I like to watch football at the weekend, and I love watching good passing or good shooting. And if you think about your favorite player, or if it's sport, it could be basketball, whatever, it still applies. Whenever somebody makes a ball move, so whenever someone passes, or someone shoots, or in basketball, someone pushes, or in tennis, someone swings, anytime someone makes a ball move, they're applying a push to the ball. So it's either with the foot is going to push against the ball, or the tennis racket, when they swing it, is going to push against the ball. And what they're doing in these cases is they're applying something called a force. So if you understand all the forces that are involved in sports, then that potentially can make you better at doing the sport, because you'll know where exactly on the ball you want to apply the force to make it do what you want to do. So if you want to make the ball curl or put a nice spin on it, the way Messi and Ronaldo can do, and make it zip through the air, then you basically need to know exactly where you need to apply the force on the ball. So understanding these things can help you make your sports better. But let's get back to the basic science concept again. Okay, let's imagine we have an object, this box here, and we have a person comes across this box, and the box is in the way. It's somewhere where it's not supposed to be, and the person wants to get the box to move. So what they'll do is they'll put their hands up against the box and they'll push it. Okay, so they'll push the box. Now sometimes that will make the box move. The box will move over this way when they push it. Sometimes it won't move. Why would it not move? Well, maybe the box is too heavy. Or maybe it's stuck to the ground. Maybe someone's played a trick on this person and they've glued it to the ground, or they've cemented it. Or if this isn't a box, if this is a wall, when we push it, it's not going to move. But you're still pushing it. Okay. So we say here that you are applying a push to the object. Okay. So a push is a type of force. So we say that you are applying, when you push an object, you are applying a force. So the force is the push. Now, not all the time do we want to push it. Maybe there's nowhere to push it to. We need to instead try and drag it. In that case, we will put our hands up against it, and instead of pushing, we would pull it. We will grab a hold of it and try and drag it backwards. And again, if it's a wall, you can't pull walls down, okay? If it's a big, heavy box that's bigger and heavier than you, then you aren't going to be able to pull it anywhere either. It's not going to move, but you're still pulling it, okay? You're still applying a force. It's just that the force isn't strong enough to make the object move. But let's say it does move and you are pulling it this way. So again, you are applying a force, but it's not a push anymore. We would now call this type of force a pull. So pushes and pulls are very simple types of force. Now, notice something else. To make either of these things happen, a push or a pull, you actually have to touch the box. Now we know that this is true because if you think about it, if you were sitting in your sitting room and there was a box in the middle of the floor and you just looked at it and wished for it to move, please move. I want you to move, push. I'm pushing you. Well, it's not going to go anywhere. If you want it to move, you actually have to apply what we call a contact. You have to make contact with it. Okay. Now, when you make contact with something, that means you are applying a force. So we call this type of force a push or a pull. We call these types of forces applied forces. So applied forces, examples of these, e.g., are pushes and pulls. Okay, so this is one type of force. Forces that involve contact, pushes or pulls. Okay. Now, not all forces are like this, and we're going to see in a second some that are not like that. So some that work in slightly different ways. Okay. So if we were to kind of summarize then, what were applied forces, we would say a key word here to do with these is that they need contact. They need contact. Okay, so we're going to take a look at a couple of different kinds of these now. Okay, all right, so I've given you one of these, okay, and that is pushing a box. Okay, so what I would like you to do now is I would like you to pause the video and try to write down at least 3 more of these applied forces, these contact forces. Pause the video and do that now. Okay, so you should only be playing this video now if you have completed this task, and that is to write down 3 forces that are applied or contact forces. Now, obviously, I don't know what ones you've written down, but what I can do is I can give you some more examples so that you might hopefully compare them to yours. Okay. So one of the ones that I talked about earlier was kicking a ball. Okay. Now, obviously, this is how forces relate to sport. So this is definitely an example that I want to include. When you kick a ball, your foot pushes the ball. Now, the ball can't go anywhere if you don't actually make contact with it with your foot. So to get the ball to move, you are pushing it with your foot. We call it a kick, but really a kick is just a type of a push. All right. Hopefully, I'm hoping that you came up with other types of ones, because both of these are pushes. Push and push. Kicking is a type of push. I want you to also, if you didn't come up with some types of forces here that are pulls, can you please pause the video and have another go at writing down a couple more examples that are pulls? Okay, so you should be playing the video now if you have done this. Okay, another one that might be a good one here that we could say was lifting a bag of shopping. Lifting a shopping bag. Okay. So when you do this, you put your hand down, you grab the handle of the bag and you pull it upwards. So lifting is a type of applied force. Again, the bag can't lift itself up. It can't just hover in the air. You actually have to grab it and pull it and lift it up into the air. Another one might be pulling open a door. Now, pulling open a door is an unusual one, okay, in that there is actually a push and a pull. So you grab the handle, you push it down, and then you pull the door open. Okay, so I'm just going to include the pulling a door open. Pulling a door open. But hopefully you came up with other ones as well as these ones. Okay, so lifting a bag of shopping, pulling open the door. What other ones? Some unusual ones maybe. Typing. Typing on a keyboard involves pushing the keys. So when you're pushing down different keys or typing on your phone on the screen, you are pushing, you are applying forces to the screen of your phone. Okay, I think that's enough for now, enough of those applied forces. But I suppose we need to think about now, when are there some forces where there are pushes or pulls, but there's no contact? Okay, so we know that pushes or pulls are forces. Is there any pushes or pulls which is the opposite, which don't have any contact? Well, take this scenario, for example. Say you are flying in a plane. Okay, so you've got a plane and you've got a little person who jumps out of the plane. Now, obviously, you're way above the ground. So let's say that this is planet Earth here. And obviously you've jumped out of the plane. So what do you think is going to happen to you? I want you to think about that. I'm going to stop talking. Okay, I'm hoping that you said the person is going to fall down. So why is it that we always fall down like this towards Earth and we never fall up? Why is that? Well, there must be something that makes or that pulls you down. Okay, so you're experiencing a pull and you are being pulled down. But what is it that's pulling you down? Because you are not in contact with anything. Now, most students, even my first year students, would know that it's Earth's gravity that pulls you down. That's what we call the pull of gravity. Okay, and we'll get to that a little bit more in detail later on. But yeah, so there's a pull even though you're not in contact with earth. Earth is able to pull you down. So you see in this example here, there's a big space between you and earth. There is no contact. So that means the force is not being applied here. Okay, it's not being applied because there's nothing applying it. Okay, there's no contact being made between you and the thing that's causing the force. So let's have a look at some of these then. So we've got non-applied forces, and these are ones where there's no contact. No contact. So pushes are pulls that work over a distance, if you like. There's a distance between the two objects that are causing the forces on each other. Okay, so I'm going to give a person parachuting. Oh no, I'm going to say actually a person falling from a plane. Okay, so why is it that they fall down and not up? Well, they're being pulled. They're being pulled by Earth, Earth's gravity, even though Earth is not in contact with it. Okay. All right, so I'm going to get you to pause the video and see, can you write down another couple of these now? Okay, all right, so I'm hoping you came up with something else. A lot of these have got to do with things falling. So you could have an example of anything falling. So here's another example, an apple falling from a tree. Okay, so an apple falling from a tree. We'll take a look at another one, an unusual, it's a little bit different. If we consider that this is, imagine that this is the ocean, okay? So here is the ocean floor, which of course makes up, or this is part of Earth, so this is the planet. Same as over here, in this example, Earth is gonna pull you down to it. Well, if we were to consider a boat that has got a hole in it, we'll say we have a boat and it's got a hole and it's filled up with water, what's going to happen to the boat? Okay, so have a think about that. What will happen to the boat if there's a hole in it and it's filled with water? I'm hoping that you're saying or that you're thinking that the boat will sink. But why? Why is it sinking? Why does it not fly? Why does it not go into the air? Of course, the answer is there's something pulling it down. So the boat is experiencing a pull and it's going to sink through the water. What's pulling it? Well, again, it's the earth. So the earth is pulling the boat down, okay? The earth is pulling the boat down, and yet again, there is no contact between the boat and the earth. So this is again a non-contact or non-applied force. So there's another example we can use, a boat sinking. Okay, some other ones that we may not have thought of before would be an engine. An engine in a car, for example, causes the car to move or makes a car drive. So it's the engine that causes the car to drive, even though it's not touching the wheels. The wheels are separate from the car's engine, and the wheels or the engine can make the car's wheels move, even though the engine and the wheels aren't directly in contact with each other. So an engine making a car drive would be another one. And one more, and you may be familiar with this idea, is if we take two magnets. So in primary school, you may have played with magnets and you'll know that they've got two ends. They've got an end that says N and they've got an end that says S. And some of you may even know the rules about magnets. So if we take a second magnet and we bring it close and say we have the S end here and the N end here, you'll notice that the two magnets, we've lined them up with the opposite ends facing each other. So what do I mean by that? I mean an N is facing an S. The N of one magnet is facing the S of another magnet. And anyway, or sometimes they'll be blue and red. So if you face up a blue end of a magnet with a red end of a different magnet, you'll notice that what they do is, even though they're not touching each other, they will suck together or pull towards each other. when we say that they are getting attracted. Okay, it's like one magnet is pulling another magnet in, even though they're not in contact. Okay, and likewise, if you flipped one of them around, so let's say we flipped the one on the right, so it was facing the other way. So we've got the two ends together and so we've got the two ends facing each other. Now they would do the opposite. Okay, they wouldn't want to go together. They would try and push away from each other. We say that they repel each other, push away. Okay, now don't worry about repel too much for now. What I want you to think about is pushing and pulling, even though there's no contact. So they're able to push or pull each other even without any contact. So let's put that one down as well. And that would be a magnet pulling another magnet. Or indeed, it might pull a piece of metal either, pulling another magnet. Or maybe it pulls a little a little piece of metal that you've got on one of your pens that will get sucked towards a magnet, for example. So lots of different little examples. So two types of forces, guys. We had applied forces, which need contact, and we had non-applied forces, which have no contact. Those ones are a little bit more difficult to think about, okay? All right, so what we're going to do now is we are going to go and see if you guys understand these by checking some questions or doing some questions down here. All right, so see what we have here. It says, see where I'm reading, these are the little challenges I've got for you. It says, for each of the questions below, write if it is an applied force and if it is a push or a pull. It says the first two have been done for you. So the first two have been done, or one of them has been done, and the second one has been mostly done, and I'm going to help you finish it off. Okay? All right, so let's read what it says. Question one here says, what happens if you take a shopping trolley around the shop? Is that a push or a pull? Is it a push or a pull? And is it an applied force or not? So if it's applied force, you want to know, is there contact or no contact? Contact or no contact? If there's contact, then we say it is an applied force. If there's no contact, we say it's not an applied force. Okay, so just a quick reminder. Okay, let's go. Taking a shopping trolley around the shop. This is an applied force because you would have to put your hands on the handle and push it. And obviously then, if you're pushing the trolley, then it is a push. So that's how we would answer this question. We write a sentence. This is an applied force and it is a push. Okay, so that one's been done for us. We're going to look at the second one now. Raindrops falling down to the ground. Okay, so think of rain falling through the air. Why are they falling through the air? So I'm thinking back to what pulls things down through the air. Well, that's the gravity, or the force of gravity makes things fall down through the air. And they're falling from the sky. So is the earth in contact with the rain all the time that it's falling? No. Okay, it's kind of like the person falling from the plane. The raindrops don't need to be touching earth for them to be pulled down. So this is a non-applied force. Okay, so you see this is not an applied force, is what we've written here. However, that's not the end of the sentence, ... I want to know, is it a push or a pull? So we're going to finish that here, and it is a what? Okay, so this is where I want you now to get your copies out. Okay, I'll get a piece of paper, something to write on, and you can copy question one, and you're going to pause the video and answer the rest of question two here for me. Please pause the video and do that now. Okay, so you should only be playing if you had to go answering this. So for question two, you should have something like this. This is not an applied force, and it is a pull. So gravity is pulling the raindrops down. Doesn't push the raindrops down. Does that mean, that would mean it'd have to be something above pushing it down. It's coming from the bottom and it's pulling the raindrops down. Good. All right, what about question three? So what you have to do is copy the sentences you've done above, but apply to question three. Pause the video and do that now, please. Okay, so you should only be playing if you've tried question three. Hitting a tennis ball with a tennis racket. Okay, so think about that motion of hitting the tennis ball. Okay, so first of all, can the tennis ball start moving if the racket doesn't come in contact with it? No. So this definitely needs contact between the ball and the racket. So what we should have written here is this is an applied force. And then the next question, is it a push or a pull? And it is a push. So the racket pushes the ball. Okay, so I'm going to get you guys now that we've done lots of them together, I'm going to get you to pause the video and you're going to go through the rest of these, please. Pause the video and do that now. Okay, all right, there's a couple of funny ones in here, okay? Hopefully you'll think about it and figure it out, okay? I'm gonna tell you that number 5 is unusual, okay? So maybe take a look at question 5 again. Okay, so let's have a look. Question 4, chewing on your food. What do we think? All right, so first of all, this is an applied force, okay? Your teeth have to actually make contact with the food when you're chewing, okay? And I wouldn't say your teeth pull the food, because then you think about opening your mouth to pull the food apart. That's not really the way it is. It's more like a crushing the food, isn't it? Your teeth are pressing against the food, so it's more of a push. So that's what I would say for number 4. This is an applied force and it is a push. The television playing a film, this is a little bit cruel, to be honest, to put this one in there, but I just wanted to see that were people able to see. For a TV to play a film, it doesn't really need to be a push or a pull, okay? So once the TV's turned on, we're not talking about turning on the TV. If you're talking about turning on the TV, you'd have to push the remote, push the button on the remote. So that would be a push. But for the TV to actually play the film, there's no push or pull at all. So basically, there are no forces. Okay, so that's that one. There are no forces. That one's a little bit mean, to be honest. There are no forces. But I just wanted to give you a chance to really think about what's going on here. There isn't any forces happening when the TV is playing a film. Right, a fire burning. What do we think? Now that we've seen number 5. Okay, so number 5, for a fire to burn, again, there doesn't really need to be any pushes or pulls. Okay, once you put the fuel on and you light it, you don't have to do anything. There's no pushing or pulling going on in order for the fire to stay burning. So again, I would say there are no forces. No forces. Dragging a heavy object across a carpet. All right, this one should have been pretty easy compared to 5 and 6, I think. This is an applied force. You've got to grab the heavy object to make it move, and you're pulling it if you're going to drag it. So if the key word here is dragging, you've got to pull a pulling force to get it to drag. Climbing a ladder. This one is definitely quite tricky. There's a lot of stuff going on here to climb a ladder. When I've done this with my students before, they've come up with a variety of answers, but many of them come to the conclusion that actually it's a push and a pull. It's definitely applied force because there's contact. You can't climb a ladder without being in contact with the ladder, but there's a push and a pull. If you think about climbing a ladder, you put your hands up, okay? And when you put your hands up, you're pulling yourself up the ladder. But at the same time, you've got your feet on the other rungs down below, and they are pushing you up the ladder. So it's kind of like you do the two things together. So your hands are pulling and your feet are pushing. Okay, so interesting sentence here. We would say this is an applied force and it is both a push and a pull. All right, so now we've looked at the different kinds of forces, or the 2 different categories of forces, and those are applied forces. And if you didn't get a chance to take these down earlier examples, you might want to pause the video and do that now. Applied forces. And then there are these other ones called non-applied forces, which don't have any contact. Okay, so if you want to pause the video again and you want to take down those. And that's it for introduction of what forces are and what are the main categories of forces. In the next video, we're going to be looking at how we can draw diagrams to always know what's going on when we're looking at different kinds of forces. All right, I'll see you in the next video.